So this is just an explanation about how to read your characteristics of stars chart on page 15 of your Earth Science reference table. So this is the chart. You will also see this chart other places. It's known as the HR diagram. In your reference table, it's just titled Characteristics of Stars. And there's a lot of information about all the different stars in the universe on this. So basically what this is a categorization of what kinds of stars there are out there and what kind of life stages they are, how bright they are, and so forth. So we're going to start off with the life stages of these stars. You'll see here that the early stage of stars is also known as the main sequence. So this is where a star spends most of its life. All the stars in the main sequence in the early stage of their life burn hydrogen for fuel, and this is where they spend most of their life. Again, this is where our sun is right here. Our sun is a main sequence star, so currently our sun is burning hydrogen for fuel. And when a main sequence star runs out of hydrogen fuel, it will move to its intermediate stage. And depending on how big it was as a main sequence star, it will either become a giant or a supergiant. So if it's a smaller star, it will become a giant, like our sun. Our sun will become a giant. Or if it's a bigger star, it will become a supergiant. And this will go on for a while, depending on how big the star is. The bigger stars will tend to burn out quicker. And when these stars end their life in the intermediate stage as either giants or supergiants, they will burn out and become these small stars called white dwarfs, these really dense, kind of weird objects that aren't very bright. And these things will live out their life until they run out of the fuel that they're burning, and then they'll become black dwarfs, which are basically just small, dense balls of nothing, pretty much. So over here on the left-hand side of the chart is luminosity. Now, luminosity is based off of how bright our own sun is. So you see here at 1, our sun lies right on that line. So anything compared to our sun is on here. So for instance, if we look at these stars up here, all these stars on this line right here are 1,000 times brighter than our own sun. Anything down here is 1/100th as bright as our sun, and so on and so forth. So all these down here are very dim stars. All these up here are bright stars, and the ones in the middle are just kind of average. Turns out that luminosity is directly related to how big or small a star is, and that is why the mass of the star is over here, or the size. So the big massive stars are up here on top, and those tend to be the very, very bright stars. And then the very small stars are down here on the bottom of the chart, which are also the very dim stars. Again, this is a direct relationship. As luminosity increases, so does the size of the star. Now we're going to focus on here on the y-axis. You see two characteristics down here. You see surface temperature and color. And again, these two are highly related. So all the very, very cool stars down here at about 2,000 to 3,000 degrees Kelvin are all red. Then when you move up to about 4,000 to 5,000 degrees Kelvin, they're all orange, and so on and so forth. So the more hot the star is, the hotter the star is, it's going to depend on the color. And the blue stars are going to be the very, very hottest, sitting here at about 20,000 to 30,000 degrees Kelvin. So this is a short explanation on how to use this. And